This is a February-March 2023 variant 42 question. 1A carries 2 marks here. We have to define gravitational potential at a point. The gravitational potential at a point is defined as the work done to move a unit mass from infinity to the point. The marks is 1 mark here, 1 mark here. So just carry 2 marks. Then for part B, Artemis is a spherical planet that may be assumed to be isolated in space. The variation with distance x from the center of Artemis of the gravitational potential is shown in figure 1.1. So the vertical axis represents the gravitational potential. The horizontal axis represents the distance from the center of the Artemis. Looking at the graph, you can see that the gravitational potential always has a negative value. As work is done by the gravitational field on the unit mass, as the unit mass moves closer towards the planet. This is because gravitational force is always attractive. There's always attractive force between the planet Artemis and the unit mass. In other words, energy is removed from the mass as the mass moves closer to the planet. This is why the gravitational potential is always negative outside the Artemis. The second point you need to know is that the gravitational potential increases as when the distance from the center of Artemis increases. Meaning the gravitational potential, you can see that become less negative as the distance x increases. In fact, the gravitational potential tends towards zero. Tend towards zero. You can see that here you move. If you increase the distance of x, the value will tend towards zero. In fact, the gravitational potential at infinity is taken to be 0 joule per kilogram. So when it's very far away from the center of Artemis, the gravitational potential is 0. Now, in this question, you have to refer to point A and point B. Point A refers to the surface of the Artemis. So you can see that the gravitational potential at the surface of Artemis is around 3.55 times 10 to the power 7 joule per kilogram. So this is positive 7. The radius of Artemis is 4,800 kilometers. You have to determine the value of gravitational potential on the surface of Artemis. So refer to point A, where the radius is around 4,800 kilometers. You can find that the gravitational potential at the point on the surface of the planet Artemis is around minus 3.55 times 10 to the power 7 joule per kilogram. That's why the answer is 1 mark here. And then show that the mass of Artemis is 2.55 times 10 to the power 24 kg. In order to solve this question, you must know the formula for gravitational potential, which is gravitational potential equals to minus gm over r. So your m equals to minus your gravitational potential times your radius divided by the gravitational constant. Substituting the values into this equation will give you 2.55 times 10 to the power 24 kg. This will carry 1 mark. And then for part 3, calculate the gravitational field strength, G, on the surface of Artemis. The formula for gravitational field strength is G equals to Gm over r squared. So again, you substitute the values into this equation, you can get the answer for G, which is 7.4 Newton per kilogram. Alternatively, you can say that G equals to the minus value of the gravitational potential divided by r. So equals to 3.55 times 10 to the power 7 divided by 4,800 times 10 to the power 3 meter. This will give you the same answer. Then in part 4, a satellite is in an orbit at a fixed distance position above a point on the surface of Artemis. The satellite is located above the equator of Artemis at a height above the surface where the gravitational potential is minus 0.65 times 10 to the power 7 joule per kilogram. Now, since the gravitational potential is given, you look at point B. The gravitational potential is minus 0.65 times 10 + 7 joule per kilogram. So it means the distance is around 2.65 times 10 + 7. This question carries 4 marks. The first mark is to get the value of R from the graph, figure 1.1, which we will take to be 2.65 times 10 + 7 meter. Then, in order to find the period, you have to use the formula either gravitational force is your Gmm/r². This is your centripetal force. If I use this formula here, then must use V equals to 2πr/t, so that you will get an expression number 3, third point here, t² equals to 4πr², r³ divided by Gm. If you use gravitational force as Gmm/r² equals to centripetal force as mr/omega², they must use omega equals to 2π/t, so that you can get the same equation here, t² equals to 4π² r³ divided by Gm. Substituting the values into this equation, 4π², the r is 2.65 times 10 + 7 to the power 3, then divided by Gm. This will give you, this will be 3 at power 3. This will give you an answer of 64,800 seconds, which turns out to be 18 hours. So this is how you get the 4 marks here. 1 mark here, 1 mark here, 1 here, 1 here, 4 marks. In this part C here, we have to state one similarity and one difference between gravitational potential due to a point mass and electric potential due to a point charge. The 3 points are given for similarity. You have to write down any one of the 3 points. You can say that the similarity, the potential is inversely proportional to the distance from the point mass or point charge. You can say that the points of equal potential lie on the same concentric circles. Or you can also say that the potential is 0 at infinite distance from the point mass. So this is a similarity. The difference is the gravitational potential is always negative, whereas electric potential can be positive or negative. This is because gravitational force is always attractive. Electric force can either be attractive or repulsive. And then this is a summary of facts that you must know to solve this question. Number 1, you must define gravitational potential at the point. Number 2, you must know how to plot and interpret a graph of gravitational potential and distance from the surface of a planet or the center of the planet. Number 3, define and calculate gravitational field strength. Number 4, know the relationship between gravitational potential and gravitational field strength. And then number 5, relate gravitational force to the gravitational acceleration it causes. Number 6, know which equation for centripetal force to equate to gravitational force. Then number 7 is know the similarity and differences between gravitational and electric fields.